Hey folks, this is Mr. Ward. Welcome back to day 2 of Matrices. We got started yesterday, day 1, really a review of an A2 topic, that is solving 3 variable systems. We're finding an ordered triple, XYZ, that fits into all the equations, and visually it's the intersection of 3 planes in space, 3 sheets of paper, like in a room, that all intersect at one unique point. All right, so to warm up real quick, we'll do this back substitution. This should be ready to go. This will actually lead into what we're going to do today. We're just going to take the variables out. A matrix, that's what it is. It's a box of numbers. So for us, we have this 3, 2, 1 idea. Z equals -2. We're going to go back into here. Y minus a -2 equals 4, which is a +2. Get rid of that +2 by subtracting. Y equals 2. Now that we know, we know 2x plus 2 minus 3 times -2 equals 10. Let's clean that up. 2x plus 2 plus 6 equals 10. Subtract that 8 over. 2x equals 2, x equals 1. So the ordered triple is 1x, comma 2y, comma -2z. If we picture ourselves in the center of a room at the origin, 1 to the right, 2 up, and -2, 2 backwards. So that third axis. All right, we're going to take a minute here. You're going to do this on your own, a little more challenging. What we did in class yesterday, day 1, we said we're going to name these 1, 2, and 3. And your goal is to go from 3, 3 to 2, 2 to 1, 1, so you can then back substitute. Why don't you pause a little bit on this video and see if you can come up with the correct ordered triple. You had ample time to pause, hopefully. 8, 1, 1. That's the ordered triple that you should have gotten. All right, enough of the old stuff. Let's move into something new, something interesting. A matrix. That's singular, matrix. One of them, plural, is matrices. CES. So if you're talking about one, don't use the word matrice. It's matrix. And what is it? It's a box of numbers, a row by column arrangement of numbers, usually associated with the coefficients of an equation or equations. Ah, that's interesting. All right, so here's the order is the size. And the first number is always rows. And the second number is always columns. So a 2 by 2 is 2 rows. There's your row 1, there's your row 2, there's column 1, column 2. So if I said, what's the number in row 1, column 2's position, you would say that's the 3. Here's a 2 by 3, 2 rows, 3 columns, 3. And a 4 by 2 is a 4 row, 2 column. All right. What we're going to do is we're going to take systems of equations, so the familiarity with what we talked about yesterday in the start of class today, and we're going to make matrices out of them, okay? First is going to be an augmented matrix. An augmented matrix uses all the numbers. And if I took the variables out, I would see a 1, 2, 8, 3, -1, 4. We're going to focus on this matrix type early. We're going to focus on this next one a little bit later in the unit. That's called a coefficient matrix. And I think this is a little more logical. A coefficient matrix is just the coefficients. So in this case, it's 1, 2, 3, -1. It's square. It's 2 by 2. But again, we'll focus on the blue one more. All right, here's what we're going to do. The process we're going to use is called Gaussian elimination. And let's read it. A sequence of elementary row operations performed on a corresponding matrix obtained from the coefficients of a system of equations. What's obtained is a matrix in row echelon form from which the system can be solved using back substitution. Back substitution sounds like what we started class with today. A row echelon matrix up above here is a stair-step pattern with the main left-right diagonal all ones and the bottom left corner zeros. So here's what it's going to look like if it's a 2 by 3. A 1 there, a 1 there, a 0 there. These numbers don't matter. And then a 3 row echelon would have all 3 of these 1s and these 3 zeros, and these don't matter. And I'm going to show you real quick why that should make sense to you when I go back to our warm-up. If I took this system of equations right here and made a matrix out of it, you would say, first row, 2, 1, -3, 10. Second row, there is no x, which means a 0. Then 1, then -1, then 4. There is no x, there's no y. 1z equals -2, as you can see, except for this 2 up here, which I'm not too worried about. That is almost in row echelon form. That is, we can back substitute to solve. All right, so let's take a look at this. We want to use the process of Gaussian elimination. We want to get a matrix in a row echelon form so we can solve it, okay? And the only 3 things you can do when it says elementary row operations are these 3 right here. The only things you can do to a matrix to manipulate it, to get it into REF, by the way, that's a shorthand for row echelon form. It relates to our calculator too, we'll talk about that later, is swapping 2 rows, multiplying a row by a non-zero number, and adding a multiple of 1 row to another. We'll talk about the meaning of those as we do them. All right. So let's take one right here. We have a 2-variable system. If I said to you solve that, you would solve it old school. You would either use elimination or substitution, or maybe you'd graph them, find that intersection point. But this is new. The process is important. So the first thing I'm going to do is I'm going to create a 2 by 3 augmented matrix. And we want to end up with it looking like this. So how do we do that? Well, I want a 1 where the 3 is. In other words, we're always going to get this one first, we're going to get this one second, and we're going to get this one third. As you get better at it, there's a little bit more openness, but for now we're going to stick to that. And remember, the only 3 things we can do: swap 2 rows, multiply a row by a non-zero number, add a multiple of 1 row to another. So the first thing I see is we're going to swap row 1 and row 2. And I'm going to write that right here. Row 2 and row 1 swapped. It tells me what I did to matrix 1 to get the new matrix. And if you think about it, why is swapping rows legal? Because all I did was took these 2 equations and put the bottom one on top, and vice versa. Of course you can do that. Of course that's legal. So we've got our 1 here. If we went back to the variables and I said, hey, how can you get x to drop out? You would say to me, Mr. Wood, I got this. I'm going to multiply equation 2 by -3. 3x plus -3x is gone. I'm going to multiply by a -3. Got it. So that's what we're going to do with a matrix. We're going to say 1, 2, 7, leave it alone. Row 2 minus 3 row 1s. A lot of mental arithmetic in matrices. You got to be good at it. You got to be comfortable. So I'm going to take row 2, 3, minus 3 times 1. 3 minus 3 is 0. Row 2, -4. -3 times 2 is -6. -4 plus -6 is -10. Row 2, 1. Row 1 times -3 is -21. 1 minus 21 is -20. Got it. I've got a 0 here. So 2 of my 3 pieces for row echelon form are there. I got 1 more to do. And if I think back and say, okay, forget about the matrix, what does this look like as an equation? You would say -10y equals -20. What would you do? Without a doubt, divide by -10, y equals 2. How do you show that in a matrix? By the way, each new matrix is called an iteration, a new matrix that's equivalent to the old matrix. Okay, we haven't changed anything. So our last iteration of this matrix, I'm going to do it in blue. 1, 2, 7. I'm going to take row 2 and I'm going to multiply it by -1/10. The same thing as dividing by -10. 0 times anything is 0. -10 times -1/10 is 1. -20 times -1/10 is 2. I have now gotten the matrix into row echelon form because I have a 1 here, a 0 here, and a 1 here. Now I can finish solving it by putting the variables back in. X plus 2y equals 7. No x's, plus y equals 2. Back substitute. X plus 2 times 2 equals 7. X plus 4 equals 7. X equals 3. The ordered pair is 3, 2. Again, not the easiest way. It's using this new method, creating them, and I want you to use the terminology, creating a matrix using Gaussian elimination to get it into row echelon form so we can then solve it. All right? Take a look at that. Stop it, pause it, go back if you need to. Let's move on. Okay, like we talked about the other day, sometimes systems are unique in that they have no solutions, meaning that the lines are parallel, or they have multiple solutions, meaning the lines are the same line. How does that show up in a matrix? Well, watch what happens. If I said to you, let's use Gaussian elimination on this matrix and back substitute, you'd say, I got it, Mr. Ward. I'm going to make a 2 by 3 augmented. And here's where you have to be a little creative, because remember, we said I wanted that 1 first, but actually you can get that 0 first if you want to. And here's why I think it's better here. The -6 and the 3 are multiples of each other. Like if you looked up the top here, you would say, hey, let's get the x to drop out by multiplying row 1 by, or equation 1 by 2. So that's what I'm going to do. I'm going to say 3, -5, 18, my old row 2 plus 2 row 1s. -6 plus 6, 0. 10 minus 10, 0. Ooh, something more happened that we didn't expect. I wonder what that's going to mean in a second. 20, 2 times 18 is 36, plus 20 is 56. And you go, is that a problem? It's not a problem, because what that means is variables back in, 0 x's, 0 y's equals 56. Can't happen. A contradiction, that would mean no solutions. Hence, in 2 variables, these 2 lines are parallel. That's how it would show up if you use this Gaussian elimination process. All right. We do have a 3 by 3 example. It looks like I'm not going to be able to finish it on the video here. We'll have to do a little secondary, but let's at least get it started. And by that I mean, let's make our augmented. Come on, let's dig in. This is a challenge. 1, 2, 1, -2, 3, 9. -1, be careful. 3, no z's, -4. 2, -5, 5, 17. And we want to end, and this would be a great place to call it, with a 1, a 1, a 1, a 0, a 0, a 0, don't care, don't care. And that's going to help us solve this system. How do we get from the red matrix to the black matrix in this brand new method? So let's first get a start. What is our order? We're going to get this first. We're going to get these second. We're going to get these third. And we're going to get this last. And it's not cut in stone, but as we first do them, it's good to have a plan. We'll do it in that order. And as we can see, and we'll probably end on this, that 1 is already there, so we got our first step done. All right, guys, I'll call it, and then we will start our new video, pick up where we left off.